start chapter 6 today. I think we only cover 3 sections in chapter 6, and then we move on to bigger and better things. That's why we're taking a quest. What's that?
Last chapter?
No. Chapter 7 is the last chapter, and it's some cool stuff. Well, 7 and then 1 section in chapter 8.
Is that like a sarcastic cool or cool?
No, I like chapter 7. It's my favorite chapter. It's a lot, very geometric.
Okay.
Very geometry.
So save the best for last.
Of course. There's only one new thing in the lesson today. Most of it is stuff we've already done. We're just going to clean it up a little bit, give it some new names, and talk a little bit more about what the AP test is going to require from you on a differential equation problem. I have a quick slope field at the end of the slideshow. Just going to use it as an introduction to slope fields because we'll do an entire day of slope fields sometime next week. My goal here is to be done quickly, so that'll give you probably, hopefully 15, 20 minutes at the end of the period where you can either start on this homework, which will be due Monday, or review for the test tomorrow. Okay? Questions, concerns, anything good of the cause? Good of the cause?
Did you have your mountain dew, your starter?
No, I'm just really excited about math. I just got a text from my daughter. She's in line at IU. She's at IU, and they have Mark Cuban. Everybody know Mark Cuban? Yeah. He's going to be a guest speaker because he's building a new building on IU campus. So she's first in line to see him. So she's going to ask him for a quick $1 million.
Wait, is that the guy that's like a multi-billionaire or something?
Yeah, Shark Tank. Yeah. He's on Shark Tank.
Yeah.
He made his money. Anybody know how Cuban made all his money?
He's like the owner of some team.
He's a tech. He owned a bunch of tech companies.
Right, but do you know what he did to get started?
He was like the music career. He was in the music business.
Nope.
Wait, which one is he again?
Records.
Yeah,
He's the
owner
first
of,
one. He's the first one to design
Starts with a D.
internet. What's the word I'm looking for? Streaming internet. He was the one that created. I think he started with IU basketball games, but it might have been the Pacers. He's the first one to stream games over the internet. Sold his first company for I think like $6 million.
Yeah, then he made like Funky Monkey, I think it was.
Then he designed another company and sold that company for $5 billion.
So he's not sitting on cash.
But he might have $1 million in his pocket that he could just give my daughter. Because that would make my life a lot easier. That's what I'm hoping for. Like just keep texting her, ask him for a loan. No, not a loan, a gift. Ask him for a gift.
How old is your daughter?
He can help
In
Kanye.
college.
What it is.
I have it.
Yeah, Mark Zuckerberg owns Facebook on Twitter.
And he was also demanding, or he was saying he wouldn't show up to the Grammys unless he was guaranteed to win for a category he wasn't even nominated in.
That's impressive.
Classic. He's where I want to be.
He's a doofus. All right, differential equations. We've done these already, differential equations in simplistic terms. Here's a derivative. What do we do to go backwards to find the function that gives us that derivative? So again, this is nothing new. We're just going to put some pieces together. So we're going to talk about initial conditions to find particular solutions. We're going to talk about slope fields and what they are. And then, of course, your goal for this week would be to learn to drive a stick shift car. Anybody already drive?
No, but we have one.
But you don't know how to drive it?
No.
Why don't you learn?
I don't know. We just haven't gotten to it yet.
Oh, it's fun.
Mine's on this one.
It's what?
Mine's on this one. No, I have a station card.
You do have a stick shift car, but it's also automatic. Oh, I understand. So you have to drive a stick shift.
Yeah.
Okay, I understand.
My parents.
All right, we've talked about this already. When you solve a differential equation, you have to take in an integral. And when you take an integral, if it's an indefinite integral, you end up with a general family of solutions. So you get that plus c on the end, which means there's an infinite number of possibilities. We're going to work towards getting a specific solution eventually. Okay, and by doing that, we're going to narrow down an infinite number of possibilities to one and only one possibility. To do that, we have to be given a bunch of information, maybe some starting conditions, something that's going to allow us to solve for c. Okay. Before we do that, however, we need to look at an example like this. So here's a differential equation, this y double prime minus y equals 0. And we're wondering, of those three, a, b, and c, which one of those satisfy the differential equations? In other words, if I put y double prime and y into the function, which of those will equal 0? This isn't a very common type of problem, but it is something that pops up occasionally. So we'll do one or two of these together, and then we'll be good to go. What's the derivative of sine? So there's y prime. What's the derivative of cosine? Okay. Now plug and chug. Y double prime is negative sine of x minus y, which is sine of x. And does that equal 0? Nope. Doesn't work. Okay. So that equation, y equals sine of x, does not satisfy that differential equation. Let's move on to b. What's y prime? Negative 4e to the negative x. Good. Derivative of e to the x is itself times the derivative of the exponent. Y double prime? 4e to the negative x. So 4e to the negative x minus 4e to the, oh, yep, sure enough, that equals 0 and that works. Now let's get rid of the number in front and let's just put the constant c in there. What's the derivative of ce to the x? Ce to the x. What's the second derivative of ce to the x? Yeah, so you see it becomes its own derivative over and over again. So of course this one would also work because we get ce to the x minus ce to the x, which does in fact equal 0. Okay. That's not a differential equation problem. That's just an example using differential equations to test whether or not functions satisfy those conditions. Sometimes they'll involve y prime, sometimes they'll involve y double prime, sometimes they'll involve both. Depends on the problem. Okay, we good? Let's do some actual differential equations. Whoops. Doink, doink. Okay, working my own computer. Okay. In case you want to see what a white screen looks like, there we go. Yeah. I'm stupid. So during fourth hour, do you remember the Big Lebowski?
Yeah.
Yeah. So somebody, Spackapans, who left this class and went to fourth hour, brought that up. So then everybody wanted to know what was the, well, I'm ahead of the game here.
Do you remember
Do you remember when that popped up on the screen?
Oh, yeah.
Yeah, I managed to forget about it until she mentioned it.
Wait, what?
I joined
Wait,
this
what was
time,
the
but
picture
I'm
again?
It's such a cheat.
What time we were
We'll
doing
talk
this,
later.
like, there's like
All right, so here's this is a true differential equation. So over the past couple years, the AP test has had one of these problems on it as one of the free response questions. So remember, the free response questions have, there's 6 of them, and they're worth 9 points. So when this type of problem pops up on the AP test like it has the last couple of years, of the 9 points, 6 of them were based on this type of problem. So usually they start with a slope field, which you don't know anything about, but we'll get to in a second, where you do 2 or 3 points that involve the slope field, which is really easy. You shouldn't get any of that wrong. Then you move into this, which is a differential equation. There is one step that you ultimately must remember, because every time I've ever seen them ask a question like this, in the grading rubric it says the same thing. If they do not do this, it's 0 out of 6. Okay. And that thing we've already talked about. The first step in solving this problem is I have to separate the differentials. What does that mean?
multiply by dx.
Right, multiply both sides by dx. So I get to that step. Now, why is that so important? Because I'm going from a derivative to a function, which means I'm going to take an integral. And when you take an integral, you have to have a differential because you need to know what variable you're working towards. If you do not do that simple step, you'll get a 0 out of 6. Doesn't matter what you do from that point on. It could be 100% correct, except for that one little step. And if you don't do it, you're out of luck. Yeah.
Why isn't it the 2x cubed minus 3x in parentheses? Or
It should be. I just got sloppy. Yeah. Okay. From this point on, it's pretty straightforward. I take the integral of both sides. What's the integral of dy? Y.
Triangle. Wait.
Y.
1/2 what's right?
Y.
Y.
Y. Just y?
Y.
Okay. We'll come back to that in a second. What's the integral of the right side?
1/2 x to the 4th.
1/2 x to the 4th
b over 2 x squared.
minus 3 over 2 x squared. Thank you, plus c. Let's go back to the left side. What's the integral of dy? Y plus c. But then I have a c on both sides. If I move the c to the other side, what's c minus c? Think before you answer. C, very good. Because that extra step would be in there, that we'd get a c on the left and a c on the right, and we just move that c over and c minus c is c, we just skip that step. And so the rule of thumb is we're just going to stick a c onto the x side of the function, or x side of the equation, I should say. So we don't. So you were right initially. The integral of dy is just y, because we're going to put a plus c over there, which gets us to that. Okay. And that's a general solution because c can be anything, any constant. So this little business over here is usually worth 4 of the 6 points, because then they're going to have you take it further to find the particular solution, which we'll do later. So as I mentioned, you must separate the differentials. Okay, we good? Nothing new there. We've done these before. Just a little bit of practice. Can I move on? We good? Okay. Slope fields. Blah, 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 blah. We'll do an example. Okay. Just going to do one today to give you an idea of what they look like. You may have 1 or 2 on the homework, but again, we're going to spend a day next week doing nothing but slope fields. A slope field is a representation of all the possible slopes of all the possible general equations based off of that derivative. Okay? So when we first started taking derivatives and we said, well, that's the equation of the, or sorry, that's the slope of the tangent line to the curve, some of you were freaked out because when we took the derivative, we got answers that involved variables. By now, you don't even think twice about it. Because, so you would have slopes like, well, x minus 1. But then we realized that if you just plug in the points, you could find the numerical value of the slope at any certain point. So there's a derivative. There is some function that when I took the derivative of it, I got x minus 1. What can you tell me about the original function? What can you tell me about y?
1/2 x squared minus x.
Okay?
Plus c.
Plus c. Okay. That's a linear term. When I take the integral of a linear term, I end up with a quadratic. If I take the integral of a quadratic, I end up with a, cubic. And then a cubic becomes a quartic, and a quartic becomes a quintic, and all that other fun stuff. This graph, this slope field, when I'm done, is going to show you all the different slopes for all the different possibilities for those plus c's. It sounds very scary and intimidating. It's not difficult at all. As I said, this should be a slam dunk, easy points. It's just a matter of plugging points into the derivative and drawing little dashes. Okay. So let's start with 0, 0. What is the slope of the tangent line to the curve at 0, 0? -1. How'd you get that? Plug 0 into the derivative, get a value of -1. So at 0, 0, I'm going to draw a little dash that approximates the slope of -1. You can see there's a whole bunch of points on that graph. I don't want to do all of them. And actually on the AP test, usually I have to do like 6 or 8 of them. We can make our lives a lot easier by doing some pattern recognition. So let's go to, instead of 0, 0, let's go up 1 to 0, 1. What's the slope of the tangent line at 0, 1? Still -1. Some of you seem confused by that. Where's the -1 coming from? Put the x value of 0 into the derivative, because the derivative is the slope of the tangent line, and get the value. Okay, so just to make sure you're all with me, let's take this point out here. 1, 2, 3, 4, 1, 2, 3, 4. What's the slope of the tangent line at 4, 4? 3. Plug in 4 for x, 4 minus 1 is 3. So then I would draw a little dash that looks like it has a slope of about 3. Okay, let's go back to where we were. Notice that in my derivative here, I don't have a y term. So in this particular case, the y doesn't matter. All that matters is the x value. So that means that all of these are going to have the same slope, which is -1. And I'm not going to do this whole graph. I'm just going to ballpark it. You want to go left or right?
Right.
To the right. Okay. What if we look at the point 1, 0 here? What's the slope of the tangent line at 1, 0? 0, which is? What's it look like? Good. Horizontal line. And that's going to continue for all of these. We'll keep going to the right. What about when x is equal to 2? 1. If I move out to 3, we get 2. So again, it's a little steeper than the last one. And if I go back the other way, I go from -1 to -2. And if you look at that, you can kind of see the general shape of the curve. Do you see the parabola in there? Okay. Which is exactly what we would expect it to be, because we know that if I take the integral of a linear term, I will get a quadratic term. Okay, so that's a representation of the slopes anywhere on the graph. And I didn't do all the points, but you can see how the pattern would eventually, as I move further away this way, it's going to get steeper and steeper and steeper until eventually it's pretty close to vertical. The same thing is true over here. And I get that general form. Are we good so far? The next step would then be, instead of looking at the general slope field, let's look at a particular value. Let's graph a particular solution through the point 2, 1. So 2, 1 is there. And this is not rocket science. We're going to ballpark this. Okay? We're going to guesstimate what it's going to look like. And so I wanted to follow the general shape of these slope lines. So it would look something like that. Okay, so that's my particular solution at 2, 1. Okay, so the type of AP question you would see is you'd be given a differential equation like that. You'd be asked to draw the slope field for that equation, which we just did. You might be asked to do the particular curve. You might not be. They just might want a general slope field. Most of the time it's a general slope field. And then they're going to ask you to solve the differential equation, which we've already done, but we'll do it again for this one. Okay, solving the differential equation is what we've already done. What's the first step? Not divide by dx, multiply. Multiply, right. Separate the differentials. That's one of the 6 points. Step 2, take the integral of both sides. What's the integral of y? Or sorry, okay, yeah, just tell me the answer, idiot. The integral of dy is y. What's the integral of x minus 1?
1/2 x squared plus
Okay, so 1 point for separating the differentials. 1 point for taking the antiderivative of dy correctly. 1 point for taking the antiderivative of the right side correctly. 1 point for just sticking a plus c on there. So now we're up to 4 of the 6 points. 5th point. This is a general solution. We want a particular solution. How do I figure out what c is given this information? Plug and chug. Put 1 in for y. Put 2 in for x. Whoops. Put 2 in for x. Solve for c. So that's 4, half, 2, 0. C equals 1. There's my 5th point, finding the value of c. And then my 6th point is putting it all together to find that particular solution. So 3 points for doing the graph and 6 points for doing this. And again, if you don't separate the differential, you lose 6 of those 9 points right off the top. So don't do that. Okay. And again, this is nothing new. The slope fields are new. But the rest of this differential equations we've been doing quite a bit of. Okay. Just going backwards, taking integrals. Are we good? Okay. So then we have, I think we're done, except I can't work my, there we go. So there's a picture of a bunch of nerds in the parking lot making a, and this one decided just not to participate.
That's lame.
Yeah. There's the particular solution right here. And then everybody else is the slope field.
Oh, it's nerdy.
Yeah, yeah.
Why is that one person off?
I'm sorry, what?
Are you in that picture?
Not as far as you know.
The bottom one is off.
The one in green?
Yeah.
So is this one, right?
That's what I meant, that one.
That one?
That one.
I don't know what that person's doing, just spinning in circles. So. All right, so this stuff is due on Monday. Your focus for tonight should be the test, but if you feel pretty good about the test for tomorrow, then you can use the rest of this time to work on the 6-1 homework. Okay, otherwise, you've got the extra questions I put on Schoology along with the answers. You've got the review to take a look at. You got a bunch of stuff to keep you busy. Para el examen mañana. Sí.
Muy bueno.
Gracias.